Look at Joe smiling. Look at him. Look at him. What are you smiling about? What are you smiling about, Joe?
I'm a happy person. I woke up on the right side of the bed today.
Well, that's really a first for that, I guess. Maybe not. Let's talk about electrical test 5 here. And we're looking at some light stuff here. This is your electrical one. These may not seem all that complicated. However, we're going to look at this. When a light is dimmer than normal, it means the bulb is wearing out. Well, have you ever seen well, that is false, but have you ever seen these bulbs? A lot of times we change out a bulb and it looks like it's silver on the inside. Don't you think that one would be dimmer even when it was burning? Is that a molecular spray thing whenever the filament goes out, or what is that? What do you think causes that?
Oh, no, is it?
I don't have a clue. I'm just asking y'all. Okay, but if I've got a let me hit you with this, and this is a troubleshooting thing. I've got headlights, Thomas. We got a headlight that's dim on one side, and it's normal. His name's Quincy, Thomas Quincy Love, yeah, or Thomas Love Quincy, is that it? But anyway, something like that. But anyway, what we're going to do here is we've got one headlight that's dim and the other one that's bright. Okay, and we're wondering, how are we going to determine what the problem is? What's the first thing you're going to do to determine why that one headlight is dim and the other one is the normal intensity?
Check the wire.
Yeah, define check the wiring. But used to, when somebody walked into my dad's shop, I saw these people walk into the shop and they hand him a turn signal flasher from one of the cars, and they say, "Can you check this?" He'd pull his pen out of his pocket, make a check mark on it, and hand it back to him. But I mean, so check the wires means what? I want a specific test step.
Okay.
In 10 words, or voltage drop, and how do you do that? Well, that's a good answer. How do you do it?
You start from I would start from where you go to the schematic first of all, then you got to find the wire.
Not really. You don't even need a schematic for what you're talking about. Now you will if you find a problem there, but
I go from the battery.
That's good.
To the power source, to the
where
light.
Yeah, where the power is on the light. You got three terminals. You need to know. You do kind of need to know which one of them is hot, right? So basically, if you go to the battery, to the one on the light, and you see voltage drop there, what does that mean? I'm talking about on the positive side of the circuit. Let's draw it.
Draw somewhere.
Somebody has my marker again.
It was over here.
Yeah, throw me that. Okay, now let's get rid of it. Everybody got this memorized, right?
No.
Black, brown, red, orange, yellow, green, blue, violet, gray, white. That's got to be in that order. You got to remember them in that order.
Yeah.
That's this right here.
I don't like your acronym for it. Yeah.
Well, that's why I'm telling you to memorize it without the acronym, okay? I'm not even giving you the acronym. I'm just telling you to memorize it. Got me? Can you do it? Can you memorize it? Come up with a different acronym. We'll use it. But I'm not telling anybody what it is. Got it?
I'm gonna have to ask Gene again.
Black, brown, red, orange, yellow, green, blue, violet, gray, white.
BBROY.
Yeah. You can remember that, right?
One,
All right. Now we're going to
That's
erase
just too
it.
many letters.
Okay, you have a pop test on that tomorrow morning. Okay. Look at that. I've already got this where you can still read it. But we're going to go to the positive battery terminal. This is the corner of the battery, and we got the battery, post on here, and we got and then here's your cable and all that. Now over here, wherever it happens to be, the dim headlight, let's say that we've got 3 wires going to our dim headlight, right? Now what do these 3 wires do on a headlight? What's the purpose of those 3 wires that's going to a headlight bulb?
You got one ground, one high beam, one low beam.
Ground, high beam, and low beam. Now you're going to put it on, you got to know which is which. Now ground is usually going to be what color?
Black.
Unless it's a Volkswagen or a BMW, and it'll be brown. All right, so here we got the ground, and we're going to say this is low beam and that's high beam. I don't know if that's the way it's really configured. It may be in the middle or whatever. All right, so here we are looking at this. Willie is going to back probe. You got to have the light burning, right? The light's got to be burning when you do this test, and current has to be flowing. Turn on your lights, put it on bright, make sure that you're on the right one, and that would be something you do with a schematic. And you're going to take a meter and bypass, like a straight pin or a T-pin or whatever, and go in there so that you don't want to poke the wire. You can go into the terminal. All right, and then I'm going to measure with my meter between here and here. And I'm going to read whatever I'm getting between there and there. And if I get voltage drop there, what does that mean and what do I do about it?
There's draw somewhere throughout the circuit.
Not draw, we're losing voltage because of resistance. Got me? And what are some possibilities? Give me one. It's not going to be here because everything else is working like it should. The only thing that's dim, huh?
A bad wire.
Possibly. What about most of your lights nowadays have got separate fuses, you know, for your low beam lights. One for the left and one for the right, so that if you lose one, you won't lose them both. But this one's dim. Could we have some? Maybe at an inline connector, we've got some had some moisture intrusion, got some oxidation, got something like that going on. So what do we do next to determine what it is that's going on?
We got to, so you already
Follow the
froze
wire.
I'm going to go to the headlight switch if it's a place that, or the easiest connector, but I'd like to go to the headlight switch if I can get to it. And I'm going to find the one that's going out of the headlight switch to the light. So what's between the headlight switch? What's between the headlight switch and the headlights? There's something between there.
Probably
It's a possibility. There's something between there.
Connector.
Relay.
Possible. Some of them, huh?
Connectors.
What about the dimmer switch?
The multifunction switch.
Multifunction switch, dimmer switch. Or if it's like an old pickups and all had it in the floor, you know. But all right, so you go from the headlight switch. Next, you're gonna do you move your voltage drop. Let's move over here to the headlight switch, and we're gonna find the one that's leaving the headlight switch, you know, going out. We're gonna close that, and we're gonna be measuring from that to this particular one. As we come together, we're gonna narrow down where our problem is. We may see it visually, and all that. So just make sure that you understand that. What if the wires have all rubbed in two except for like maybe two strands and they're getting really hot right now? There's all kinds of stuff you look at. Anyway, if you got a dim headlight, okay, let's say that you measure voltage drop on the positive side and you get nothing. You get no voltage drop on the positive side. I'm going to go to the ground side and do a voltage drop test between the negative battery terminal and the ground on that bulb.
So that terminal that you drew up there, that was the positive terminal.
Yes, the negative terminal, exactly. You're going to go from positive to positive, and that's how you do a voltage drop test.
And then you're going to go from negative to negative.
Negative terminal to the body, to the negative part of the bulb. And you'll find the problem, that way you'll find which side it is. Now what if you run into, what if you have a problem with the ground side of that bulb? What can you do really quick to keep from the repair from taking a long time?
Just ground it straight to the body.
You can go.
Patch it in and go to a good ground.
Yeah.
You don't have to, you know, the best electrician in the world just runs another wire. You don't have to find exactly where the problem is, unless it spider webs out all over the dadgum car. You know, if it's courtesy lights, and it splices in it right here, and it goes here, and it goes there, and it goes here, and it goes there, and it goes there, you know, you're going to have issues with that. Okay, the most common LED color is green.
False.
That's usually red, isn't it? Because LEDs have filaments, they're less likely to require replacement.
Excuse me?
That's true or false? Because they have filaments?
No, they don't have filaments.
Mm-mm.
Excuse me is not an answer.
They do not. A typical headlight switch has 3 positions.
No, it's not
Close
that
them
too.
and off.
What about park lights? Off, park, and head.
Yeah, 3.
That's 3.
Okay, so.
Some headlight switches, and you'll be able to see it in the schematic, will have a circuit breaker built into the headlight switch. If the headlight switch directly turns on the lights, for years and years and years, the headlight switches that look like this one here, see this headlight switch right here? Have you seen a headlight switch like this one? You probably sell them over there, right?
Yeah.
This kind of headlight switch here. Inside, internal to this headlight switch is a circuit breaker. And if that circuit breaker goes bad, you'll see your headlights blinking off and on randomly. Tick, 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 tick,
See
tick.
that on diesels all the time.
Yeah, and this particular one, you see this little button? You see this button? Now this is the way it is on a lot of vehicles. There's a little button right there. Now you know the one. This is the one you pull out, like the one on the Bronco. It's like this. You pull it out, and the way you get that little knob out is you reach up in there and you find this button, and you mash that button, and then the knob will come right on out. Sometimes you got to mash it and jiggle the knob, but it'll come out of there, and then you just take your headlight switch out, and it's like this. Now one day there was a lady that came into the dealership, and she had a Jeep with a burned up headlight switch and a burned up connector. And she was on a trip, and this was Friday afternoon.
Like when you say burned up, like it
Destroyed, it got
and-
hot and it melted.
Okay.
Okay, but there's nothing wrong anywhere, but here it was just an oxidation thing, and it melted down because of the current, and all that. You know, the oxidation cycle happens and it starts to create resistance. Resistance makes heat. That makes more oxidation. That makes more heat. Next thing you know, you got a meltdown, current stop flowing. That's fairly common, especially if somebody added extra lights, like running board lights and all this other junk, and they just scotch locked into that little bitty brown wire that feeds your tail lights, and that happens all the time. But anyway, this particular one, so think about this. You got to be a problem solver now. She comes in here and she's on a Jeep Cherokee. She's got a switch that looks like this, only the switch configuration is different. It's the same top switch with the same number of terminals and the same kind of functions as a Ford, but her connector's destroyed and her switch is destroyed, and we got no parts, and she's on a trip. And this is Friday afternoon.
So did you modify it for
Flip
it?
switch.
Huh?
Flip switch.
No, what I did was we had a switch like this for a Ford, and we had the connector for a Ford switch.
You modified
So I just
it.
looked up the schematics of the two vehicles, and I took the switch connector from the Ford and put it on there appropriately, connecting the right wires to the right places. And I put her a Ford switch in there, and I plugged it in, screwed that in there because this is kind of universal, and I slid that thing in, and we had this one came off of a Jeep right here. But I mean, we had a brand new, she had a brand new headlight switch, but I had to put a note on it saying that this particular switch is a headlight switch from a Ford pickup or whatever it was. So that the next person that took that switch out of there to replace it would give me, would be able to say, okay, I need to get a switch for a F-150, 88 F-150 or whatever it was. So, I mean, there's ways you can do this safely and right so that she doesn't feel any different. She's pulling the headlight switch out. She's got dash lights. Everything worked just like her switch. But these were close enough in the configuration, the way they were mounted. Her knob even went in there, see? So if you're thinking outside the box, you can make this happen. We used to have some motorhomes that the little stoplight switch was a little plastic thing that was okay for a Ford pickup, but they had great big massive bulbs on lights on the back of this motorhome for tail lights and all, or stoplights, and it burned up the switch. Okay, now think about this. This is electrical one. Our objective is not to hurry up and get through with the thing so that somebody doesn't go to sleep. We're trying to teach you something. I've got a switch.
Sounds like you can go to Radio Shack, buy a toggle switch with it off and on and wire it up.
Yeah, you could.
That's what I did.
But you can't do that with stoplights. You can't do a toggle switch. The stoplight switch looked like this. It was a silly little black plastic thing that had threads on this, and it'd screw in there, and it burned up internally. We had another switch, so I put another switch on it, but it's just going to burn up again, ain't it?
Yep.
Okay, so we've got B plus coming in here, like that, and this is going out to the stoplights. Obviously, it's going through the turn signal switch and all that on the way to the stoplights, because when you have your foot on the brake and you turn on the turn signals, one of the stoplights needs to flash. So this is going to go through the multifunction circuit. Okay, so I'm going out to my stoplights, but I need to modify this in a way that's safe, that makes sense, where they won't have any more trouble with it. How are you going to do that? What I'm going to do is I'm going to take and I'm going to install a relay. We had some relays that were like the one that I've got in here. This one, particular one right here. Oh no, we're dropping bulbs. This particular one right here is the kind of relay I use. I use the relay like that one because I had the connectors. I had the connector shell in the parts room to fit that one. All right, so I took that, and we've got this relay right here. Okay, now somebody tell me how I'm going to insert that relay into that circuit so that it's going to make those stoplights work anytime they mash the brake. We're not going to have anything that's going to keep them from working or have any danger.
Okay.
You're going to cut the wire?
Well, what you're going to need to do
Is
is you're going to take this right here. You're going to leave this.
That makes perfect sense.
Huh? Yeah. You're going to take this relay, and you're going to, this battery power, and you're going to put it here. Right?
Yep.
All right. And then you're going to take this wire that's going out in the lights, and you're going to cut that, and you're going to put it right here. You got it? And then you're going to ground this. Then you're going to go up here, and you're going to go right there. What happens when you mash the brake? This switch is carrying nothing but the coil on that relay, and then this is going to go. Oh, excuse me, I'm writing that up wrong. Duh! It's going to come to the normally open, and as soon as that relay clicks, it's going to pull that over, and you got stoplight power that's being carried by a relay that can handle 30 amps.
That's good.
You're taking the load off the switch.
Very similar. You're basically putting the switch doing nothing of that. Now I did that on an Explorer one time in 1995 that had burned up the headlight switch on a trip to Tennessee. And what happened was, they comes in here, the headlight switch was destroyed. It was a little plastic headlight switch that wasn't all that strong. And so I said, and I had another connector for it because it kind of destroyed it. And they said our headlights, were messed up, got to where they wouldn't work. And so I took a relay and did this. I got a Ford relay that pulls the fuel pump, got the connector, mounted it behind the headlight switch, fixed it so the headlight switch was turning on the relay, and the relay was turning on the lights. And put it all back together and wrote up that I had installed and inserted a relay to stop that from happening. Now this is an interesting story, so stay with me, okay? I came to work here in 2001, and I'd been here about 3 months. I get a call from some guy in Dearborn, Michigan, and he says, "Do you remember a 95 Explorer that you fixed the headlights on by putting a relay in there?" And I said, "Yeah, I remember that." He says, "Well, there's a whole bunch of those vehicles with the same kind of headlight switch on them over in Europe that are burning up headlight switches, and I'm supposed to come up with a field fix. And I noticed the one you fixed never came back in for repairs at any other dealer, and so I need to know what you did, because I need to publish what you did as a field fix for the cars in Europe." Isn't that an interesting little deal? Of course, I thought to start with I was going to be in trouble because I'd modified something, but it wasn't anything like cruise control or airbags or nothing that's going to blow your head clean off like a 44 Magnum, So I says, okay. I went on there, I got paint, Microsoft Paint, and I put a relay in there, and I drew him a schematic that looked like it came out right out of the Ford manual, and I emailed it to him, and he had his field fixed.
Nice.
And he published it for over there, and I said, this is what I did. Anyway, but the thing about it is, this is what got me. With all due respect to this guy from Ford, he's an engineer. And he's probably an electrical engineer. And if he couldn't figure that out without calling me, but he wanted a tried and true fix, because he didn't want to publish a fix that wouldn't work. And I said, I even gave him the part number for the relay, the 9350, the green fuel pump relay on the older stuff. And I said, it mounts right in there. It fits really good. If you took that dash out and saw that relay, you'd think that was factory because of the way that I did it with the heat shrink, the solder, and the convolute tubing and all that. Anyway, I was tooting my own horn a little bit there.
Did he give you credit?
Huh?
Did he give you credit?
He gave me nothing except thank you. That's all I got. All right. Let's see. A typical headlight switch has 3 positions. We got that. Seal beam bulbs contain the filament, the reflector, and the lens in one unit.
Yes.
That's the number 5. Okay, if the tail light fuse is burned out, the panel lights are also out. Yes, that is true. That is absolutely true. And the reason for that is, what we do is, if you look at the schematic on most vehicles that I'm aware of, and I'm sure there's some out there I don't know anything about, that are different, but they'll have the tail light fuse, they'll have the dash light fuse downstream of the tail light fuse. Basically so that if the tail lights blow, you lose your dash lights. Now, why would they do that?
So you know.
So you know, he's smart, see, so you know. You want to know if you don't know your tail lights are out, you got some issues. My son rear-ended a pickup truck in the fog down there on the way to school one day on his little car because he was out there in the fog with no tail lights. And he couldn't see it, and it was the most dangerous place to drive is when you're not used to stopping. If you've been going that road every day, and all of a sudden somebody stops and they're not used to stopping, and you're liable to, just run into them because you're not used to stopping. That's what happened there. Totaled out his little car, blew up the airbags, just ruined everything. Let's see. The brightness of the panel lights is controlled by the rheostat.
I say true.
Okay, that is false. But that is. I don't know why they said that was false. The answer key says it's false. But there is a rheostat. Like that's what this is right here. On this switch right here.
Yeah.
That's a little rheostat. And I don't know. I'm gonna put true on that. Let's put true on that because I disagree with the answer key on that. I don't know what they're thinking about. Oh, and here's one. And I've said this one before. Let's somebody comes over here to you and they say, when I mash my brakes, my dash lights come on. Remember when have I talked about this in the room? Huh?
Yeah.
Do you remember what it was? Don't you hate it whenever somebody told you that and then you see it and you think, man, what did he say the problem was with that? I mash my brakes and my dash lights come on. Because it'll be a little dim outside where they can see the dash lights. Mash the brakes, dash lights wake up. What are you going to do to fix that? Well, you're going to troubleshoot it.
What was that? Brake light?
The bulb is out.
No, it wasn't out. Let's look at how the bulb was made. All right, I've got a bulb here, and I got two little solder bubbles on the bottom of it, and I got two elements in here. All right, like that. Okay, now where does the bulb get its ground?
From the sides.
It gets its ground from here, right? If it's one of them brass bulbs. Okay, now where do these darn things go?
I guess one's gonna be powered from one, one's gonna be powered from the other.
That's right. So this is like this, right? Got it? Okay, so this one here is going to go there,
Little one.
and this one here is going to go there. Got it?
The little one's the bright lights, right? The bright
Yeah, well, no, the little one is actually going to be your tail light, and that's going to be your stop light the way I've got it drawn. I mean, basically. Okay, what happens, do you suppose, if these two wires right here get together?
Oh, God.
You mash the brake, it fires this up, it backfeeds all the way through that that fuse I was just talking about, and it wakes up those lights. So somebody comes over here and says, I'm beating my head against the wall, I don't know what to do with this. And I says, take all of the bulbs out of the tail lights, your stoplight bulbs out. So they do that, and hey, the problem went away. I said, one of those bulbs is bad. Put them back in one at a time until that problem comes back, and then replace that bulb, and you're good to go. Well, it's easier a lot of the time than you think. Like, what if somebody told you, I set my daughter up on top of my pickup when we were in the, sitting out there, and now that we've blown the fuse for the interior lights.
By sitting your daughter on top of the truck?
Yeah, she sits her daughter on top of the truck, and now the fuse is blown for the interior lights.
That don't make sense. Well.
Sort of, because what's back there, the interior lights back there, and when they built the truck, they ran a screw through that little connector, and it's only about this far from the top of the truck. He sets his daughter up in there, and it oil cans the top end and touches the screw, and pow, it blows the fuse. And so that's one of those kind of things, you see. All right, let me see here. Huh? Yeah. All right, the ambient light sensor supplies normal power to the lights for nighttime driving. And that is true. Ambient light sensor. You're gonna, so why would you want to have the lights any dimmer than for nighttime driving? Daytime running lights, y'all. You know what daytime running lights are for? What are daytime running lights for? Daytime running lights are so the other cars can see you. It ain't so you can see the other cars. Your daytime running lights makes your car visible to other drivers. Have you ever been driving in the rain and saw somebody come out of the rain on a white pickup truck with no lights on, and you could almost hit them?
So they don't have this, okay.
Yeah, if they got lights on, even like in Canada, everybody's got to have daytime running lights. These Chevrolet pickups that's got them little lights down here on the thing, Chevrolet got smart, and they said, why don't we just put some automatic daytime running lights on that the driver ain't got nothing to do with? Well, the problem with that is the driver don't know they out. Well, somebody tells them, and it ain't against the law down here. It's not against the law in Alabama to drive with your park lights on, you know that? In some states. Well, somebody told me it was against the law in Alabama to drive with just your park lights on, but I don't know about that.
I have never seen anybody get pulled over for that.
No, if you put fog lights above the bumper though, you will.
Really?
Yeah, if you put a set of fog lights in the grill of your car above the bumper and turn those on, excuse me, they'll say, excuse me, Melissa, did you know how fast you were going? Did you know that this license is expired? Excuse me? That's one which I got to get my driver's license renewed too. I'm glad I said that. All right, let me see. The disadvantage of a heavy-duty flasher is the flash rate will not change if one or more bulbs is burned out. Now, this is a kind of a dumb question, and the reason I'm saying that, some of the round flashers, and I used to have one on this floor, right here, see this one here? You see these little round flashers, like this right here. The round flasher that the manufacturers put on the vehicles back in the 60s and the 70s was set up so that in order for this thing to flash, it had to have a certain amount of current going through this little thing. And it's got a little bimetal strip in there that heats up and cools off, ding, 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 and it makes that noise. Well, nowadays they got all other kinds of flashers with electronic relays and all that kind of junk. They actually got flashers that look like a relay, but they're a flasher. They're a little bigger than a relay, so you can't put them in a relay socket, although the terminals are configured the same. Anyway, the one that I originally put in here, if you blew a bulb, they wouldn't flash because there wasn't enough current to make this flash. Well, if you get one from the parts store to replace it, it'll flash no matter what. Well, what do the electronic flashers do when you blow a bulb? Anybody know? tinka, 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 because it's measuring the current and it changes the flash rate of whatever bulb is flashing. And all that, I can show that on that board up there. And we can wire them up so there's only one light and they'll blink a lot faster. Anyway, that's how that works. All right, now then, let me see here. So that is true. The heavy duty flasher, if you put one that's not factory in there, it's going to flash no matter what, which I like that better anyway. Backup lights and hazard warning lights are included in the daytime running lights. That's not true. The daytime running lights are kind of all by themselves. They used to have a module that was send a pulse width modulated signal out to the daytime running lights, and then they started putting resistors in there, and then, like I say, GM got smart and said, why the heck don't we just put some little lights in there to come on? You know how to make the daytime running lights come on a Chevrolet pickup?
Put it in sunlight.
Back out into the sunlight, put it in drive, and wait about 40 seconds, and they'll pop on. That's how you do it. Or you can cover up the, you can shine a light on the sensor. Which of the following is not a major component of the headlight circuit? What about the license plate light, y'all? The headlights switch circuit is actually driving the dome light, isn't it? Actually, well, wait a minute. Is it the headlight or the tail light or what? Is that a bad question? You can make a case for the dome light like Melissa did. You can make a case for the license plate light because that ain't part of the headlights, although the headlight switch turns it on, but that's a different circuit. Listen to this. If you see the headlights like on that one up there, you've got a different power feed coming into that switch to feed your headlights than you do your taillights. You got me? You got a big wire coming in for your headlights, goes out to your headlights through the dimmer switch. You got another one coming in, a different power feed through a different fuse for your taillight circuit. So make sure you understand that. But on that one there, I will accept C or D. Which color is not used as an instrument panel warning light? Number 12, which one would it be?
Amber.
Believe it or not, it's yellow. Amber is. I think amber is that little orange light that you ever check engine. That's what they call amber.
Yellow.
Yeah. They don't have a yellow light. They got. Now, how many of you guys are old enough to where you've driven a car that had a light on the dash that came on and it said cold?
Yeah.
Remember that, Willie?
Yeah.
In the 1960s, a lot of the cars, when you cranked it up until the engine got warm, the sensor had two terminals on it, and one of them was grounded when it was cold, and the other one was grounded when it got too hot. So there would be a green or a blue light, and it would come on and say cold. And we would sit there on those cold days, and we said, "Man, I know it's cold. You ain't got to turn on your light." Like they did away with that because there was no point in it, you know. I mean, I think it had something to do with warming it up. When diagnosing lighting problems, remember that light bulbs are connected in what?
Parallel and series.
Okay, that's. Depends on which light bulb. Well, which light bulbs are connected in series?
Turn signals.
Loadings.
Turn signal. Actually, they're all connected in parallel. Every light's got its own ground. That's the point. If every light's got its own ground, it's connected parallel. If a light has to depend on another light for a ground, if it's coming through another light on the way, now why do they not do that?
Because if one goes out, they all go out.
Yeah, you kill them all. What's the color of the brake indicator light?
Red.
Red, isn't it?
Yeah.
Yeah, okay. What if I crank my car up in the morning and my red brake light is on all of a sudden and it wasn't on before, and I check my park brake and my park brake's not engaged, and I say, well, I'll have
brake
to.
fluid.
Yeah, we gotta, and I drive about a mile, and then the red brake light goes off.
The brake light goes off.
Yeah, after I drive about a mile, and it happens every morning.
ABS sensor.
Check your booster, maybe.
Huh?
I know you've done it in my car before I changed all day.
So you changed the oil and made the brake light quit working. I bet you probably added some brake fluid too, didn't you? Yeah. See, Joe was right. But what you do is, if the brake fluid expands with heat, and so if it's showing a little bit too low and it's turning that light on, it gets hot with the engine compartment. It swells up and raises it up off there. So that's, anytime you hear somebody talking about that, add some brake fluid. What you gonna do? Why do you have to add brake fluid on just about every single car? My Taurus right now is a little bit low on brake fluid. Why?
Because nobody ever checks it to make sure that it's all the way full.
Well, where does it go though?
You figure it's
Yes,
the
it
same
evaporates.
unit. so
Goes
it's
into the
not
calipers as the brake pads wear, right?
yeah.
There you go. Makes sense. Color of the ABS indicator light is what?
Amber.
All right. Now, you guys got matching questions?
Yeah.
You do. Okay. Number 16. What uses a tungsten filament placed in a vacuum inside a light bulb?
Is that the HID?
J for vacuum tube fluorescent. Right?
I would say incandescent bulb.
Oh. Dang.
An inert or chemically inactive gas is halogen. Yeah, that makes the light burn brighter, doesn't it?
That's what all those stupid blue light people are, right?
This right here is a halogen light. Plain old headlight bulb's halogen. That is a little capsule of compressed halogen gas, and whenever you light that thing, that filament with that gas in there, it makes it burn a lot brighter than it would if it just was in a vacuum. Somebody discovered that. That's why on these right here, you don't touch these with your hand, because if you touch them with your hand, whenever you plug them in, the grease from your fingers causes it to start to blister and it blows the bulb. Or if you scratch it, it can go and do that, and then a little bit piece of glass go in your eyes. You got to go get your eyes cleaned out. Huh?
Which ones are blue? The ones like you'll be driving and then
They've got some that they purposely make that are stupid blue. They've also got high intensity discharge stuff that's got an electric arc in there, but they got to have a module driving them. Who was it that was working on that Cadillac last semester, and the high intensity discharge module in the bottom of that Cadillac headlight bulb was destroyed by water that got into the headlight?
Kelly, I think.
Huh?
I think it's Kelly.
Yeah.
Probably was Daniel Kelly, yeah. But anyway, but that's a little, yeah, and that was crazy. All right, so what is a gauge that uses electromagnetism to move an indicating needle?
I'd say analog display.
What do you think, guys? That's electromagnetic display.
Is it?
Yeah.
Mm-hmm. Okay, an electromagnetic gauge is also known as what? That's an analog display.
Yeah, damn it.
You go, boy. All right. Used in 7 or 11 segment displays to form letters and numbers. Light emitting diodes. A display that produces light in a manner similar to a television tube.
we don't have tubes anymore.
That's going to be J. Vacuum fluorescent display. You got it? All right. A panel placed in front of an incandescent or halogen light bulb. A panel placed in front of an incandescent or halogen light bulb.
NVRAM.
It's a liquid crystal display. You know what liquid? You know how that liquid crystal stuff works? Have you ever had a pair of polarized sunglasses?
Yes.
If you have a pair of polarized sunglasses you don't care about anymore, or maybe you got 2 pair, break that pair of polarized sunglasses in half so that you can hold 1 lens in each hand, right? Put those lenses together and then turn them, and you'll get to a point where no light at all will pass through those at all. You turn them back, they'll get to where you are. And that's what polarization is. It stops every wave of light except for one. So if you turn it so they're at right angles to each other with those 2 lenses, it's completely dark. You know where I learned that? 7th grade science class. Our teacher came out with 2 pieces of polarized glass, and she explained how they work. And I never forgot that. And the liquid crystal display works the same way. It actually blocks the beam of light. You know, it's got 3 layers in there, and so whenever it it changes the thing back and forth. You know, as each segment is lit up like it. It boggles the mind, you know, to see all that stuff. We're talking $400 credit here, man. All right, I think I'm going to have you buy me some lunch today with this. You know, all right, I'll take that one. That really feels good too. There's that. And what's this other one? Oh, that's that. Yeah, that's that other one from supply. Yeah. And they're supposed to charge me for that battery pack too. Did you give that? Okay. Okay, there you go. Where's that? I got a jumper pack. By the way, which one of you guys have not wired up the fans on that board right there so that they would work?
I haven't wired them up yet.
Now, when you wire them up, put the appropriate ones on the desk there. But whenever you wire it up one time and you get it working, you're not done. What you need to do is wire it up several times to where you're comfortable with it, and instead of by hook and crook getting it working, yeah, I got it working. Okay, I'm done. You know, anyway, it works. Okay.
I need to do it at least 12 more times.
Or 14. All right, let me see here. A digital odometer mileage data is stored in this chip when the ignition switch is off. What kind of chip is it?
NVRAM. The non-volatile RAM.
Non-volatile. That means that it doesn't lose power when you shut it off. That's the D, NVRAM. Okay, number. A lamp in which light is produced when high voltage arcs between 2 electrodes.
That's the HID.
High intensity discharge. the small wire-like conductor inside a bulb.
Fill it.
I had on some of the fancy, let me just say this so you don't get in trouble and get fried. You know, some of these fancy liquid, these really bright high mount stoplights like you see on Explorers and stuff, that thing burns on 40,000 volts. Do we have anything that we can measure 40,000 volts with? So whenever you find one of those that doesn't work, if the little module that drives it has got power and ground, you replace the whole shooting match. Don't get up in here with your meter and try to measure this 40,000 volts, okay? So you just think, you know what I'm saying? I thought I would just try this. Zap. Then you're
Is that what we got those little red voltmeters for?
No, I don't know if I would go there. You know, might blow them up. You know.